So the IUPAC notation retains a close connection to the systematic organic chemistry notation. The N represents the number of carbons in the whole molecule. Okay? The number of double bonds follows the number of carbons with 2 separated by a colon. The location of the double bond closest to the methyl end of the fatty acid is indicated by the N minus. So, for alpha-linolenic acid, there's 18 carbons in the molecule, 3 double bonds. N minus 3 is the double bond closest to the methyl end. Okay? And this is why it gets tricky, because the N minus notation starts C1 from the carboxylic acid end. The W notation starts C1 at the methyl end.
What?
So the N starts from the like you said, the N starts from the
No,
so it's
the end is the other way around.
N from left, W from
Yeah. So okay.
The
So
methyl
then,
end of the fatty
an
acid.
alternative system called the omega notation proposed by Holman recognizes that the systematic organic chemistry numbering book designates the carbon next to the carboxyl as alpha and labels the last carbon in the acyl chain all the way down at the methyl end omega. So the first double bond counting from the methyl end of alpha-linolenic acid appears at the third carbon from the methyl end, right? And hence is designated W3. So both of these, the W part or the N minus part is in the same place. It's only what number the carbons are, which is why I didn't put any numbers in carbons. So if we go back to our thing.
2 ways to write the exact.
Exactly. So, and they are used all the time, right? Like you hear omega-3 fatty acids constantly, but you can just as equally see this notation, and N minus makes more sense when you're drawing a molecule, honestly, like because it tells you what to do. So, if you're drawing this molecule, right, if you want to write it in N minus and I ask you to number the carbons, here we are this way, okay? But if we're in omega notation, so I'm now going to have to put subscripts along here. Okay, so now here's the omega version, right? So the alpha carbon was this one, but we start numbering here. This is 1
Can't see
omega,
anything.
2 omega, 3 omega, 4 omega, 5 omega, 6 omega, 7 omega, 8 omega. So now I'm going to give you a specific example.
So how would it be 8W3 if it's not?
So because there's still 8 carbons in the molecule, and then the third one in is the site of the first double bond. It just happens that this one works out both ways. Here, let's do a problem. It'll make much more sense if we do a problem. Okay, so draw is what?
Isn't it the 5th one when it reaches it?
In omega notation.
So in omega, but it's still the third card. Yeah, it's still the. But seeing, right. This is why it drives me totally batty and why I mess it up every time. So let's just do a problem. It'll be much better. Okay, draw a number. This. Okay, so you're gonna draw 10. No, 6. I'm not gonna be here all day if I draw 10. We're gonna draw a 6 carbon molecule. Okay. It has 1 unsaturated bond between 3 and 4. Okay? We're going to number it starting at the methyl end, which is, which one is that? That's N minus, right? Mm-hmm. Okay. So, in order to do that, because I just wrote that over there somewhere else, so I don't need that. Okay, so we've got 6 carbons. 1, 2, 3. Right, 1, 2, 3, 4, 5, 6. Right? Okay. That's our double bond. So, if we have 1 double bond, so we're right. So where's the methyl end?
The right.
1, 2, 3, 4, 5, 6. So this is 6, 1 double bond, right?
N minus 3. Okay.
That's it.
Well, what's the W?
Okay, so the W ends up in the same place, the numbering is just backwards. Okay, so for W, right? Okay, so here's our 1, and I'll notate this one, sorry.
Okay, like this one makes sense, but that one, if you're counting it, that's at 5W.
Exactly.
But how's
And-
that 3W?
Let me read what they say in the book, because they're gonna do better than I do.
Like, I get this
Because
one.
because you go in opposite directions, but it's not always the same. We're using really short molecules, so it turns out that, like, if you're using really long molecules, it's not always the same. Because you're talking about being from one end versus the other, and also counting in the opposite direction and subtracting. So here's the, okay. So although the IUPAC and OMEGA numbering systems technically refer to different carbon atoms, right? Because a double bond is shared by 2 atoms, right? This is a double bond which has both, this carbon has the double bond and that carbon has the double bond. They're the same. So the omega is numbering one of them because you're going in reverse order, and the N minus is numbering the other one, but you end up in the same place. Question?
So the omega for this molecule here, can you just go over where that
Yeah.
is?
Yeah, let me read the rest of the sentence and then we'll do the rest. Okay, so although the IUPAC and omega numbering systems technically refer to different carbon atoms, the N and omega nomenclature effectively designate the equivalent fatty acids when the numerical following the N or the omega is the same. For example, 18,3, N minus 3, and 18,3, because there are 3 bonds. Here, we'll put that one in there. Right, 8,1, sorry, omega 3. Designate the same fatty acid. So, how can I put this any better? I told you, it's just like my worst thing ever. I totally